So now let's get into more detail about what standard WIP is, how to calculate it, and how it's useful for you. So as I mentioned earlier in previous lessons, standard WIP is the prescribed level of materials that are needed to keep your standard work operating smoothly. So in standard work, we define the amount of work in process. That's what WIP is. And that is set up in a way that makes the work continue to flow. So how do you make it flow properly? Well, the first thing is you have to come up with a set of general rules for your organization. And these are some basic ones that are very commonly used. And the first one is a very obvious, and that is that each person in your operation, each person who has their own standard work, remember an individual standard work is for an individual person. If you have two people working together, they have their own standard work that meets up where they need to do work in tandem. So each person will have their own standard work. And it makes sense if you look at the picture over here. The operator in the bottom who's working at station 5 has one piece that they're working on, and the operator in 4 has one piece. And if you had more people in here and you did a full rabbit chase where everybody was kind of at each station, you would have additional work for each person in there. And just a little sidebar, this is called a U-shaped cell. Often you'll have more than 5 stations, and you may have different levels of work that you can accommodate, different tack times. If your demand changes and you get a different tack time, you can have one person or two people or three people, and each time you'd have a different amount of standard WIP because each person would need their own. Now, in addition to one for each person, every time you have a handoff, you'll need an additional piece. And this is to make sure that the work flows smoothly if people are handing work off. Now, if each person goes through and does the full, like I said, it's called a rabbit chase because each person will go through all 5 stations on their own, and you just add more people in. There wouldn't be a handoff. A person would be carrying their work completely through on their own. But if you have a situation where one person, and like in this case, one person goes back and forth between stations 1 and 5, and one person does 2, 3, and 4, you can set it up whatever way is better for your operation. In this case, because there is a transition, you have locations for each side over here. And as you actually progress, you will see the way the setup is. So in this case, you can see that this person over here just finished work at station 1, dropped a piece off in this holding area, came over here, picked the one up over here, and started working on it. Now, as they finish up and move over, this person is going to finish their work, drop it off in this transition WIP, this Kanban, and they'll go over here, pick up this piece of work, and start working at station 2. So it's used to make sure that there's not a high degree of synchronization required if there's some flexibility, or not flexibility, but some variability. And you'll find that most standard work does have some variation to it. Different things happen. You drop a wrench, you fall a little behind, and you don't want one person's mishap to affect other people. So you try and limit this with this defined piece of additional standard WIP. Now, in addition to that, you will have a piece of WIP for each automatic machine. So this is a machine. When I say automatic, it's when you put the part in, press the start button, and walk away, and the machine does the work on their own. So this might be a testing machine. It might be some kind of press fit where you put the part in and press the button, and it does all the fitting, attachment, or crimping, or whatever it is. But, well, your operator is not at the machine, so the work is being done. And if you have, obviously, if the operator is going to go and continue on, they need work still, but they also need a piece of work in the machine. So in this case, as the operator has a piece of work in station 2, there'll be a work that's finished in station 3, and at really high levels, there you can use an auto ejector. So that's called hanadashi. It's a Japanese term, and it's just an auto ejector that kicks the part out once the machine is done. So the person at the operator at station 2 can go and load it right up. And if you have a bunch of machines like that in a sequence, they call it a chaku line, or load line. So you just load it in and then go to the next one, load it in because the parts have been kicked out. So in this case, they would load the part in station 3, and then the part that was just finished, they walk away, hit the start button, and now they're working on the part that they just picked up. So you have automatic machine parts too. And there's one other case, and these are special situations and they're not very common, And there are cases where you might also see some standard WIP involved in your operation. And these are basically things like if you have painting where you paint something on there, put down a decal on it and it has to cure or dry, or some kind of glue or any kind of process where it's a time-based process. So you put glue on something, apply a decal or, glue two components together, and now maybe it needs 10 minutes to cure and your tack time is 2 minutes. So if that's the case, you can't just take the part and you can't just stand there for the 10 minutes waiting. So what do? You create a queue of parts that are drying, and you'll have, if it's 10-minute drying process and 2-minute tack time, you'll need 5 parts in there. So when you get a fresh one, you just put the glue on, you put it at the end and take the one that's been there for 10 minutes and walk away with it. So your standard whip is based on the processes. There's a little math involved, and you just have to kind of figure it out. But these are batch processes that have to have a defined standard whip. And now you don't just go crazy on it and put, 20 parts in there just to make sure you have enough. You get clearly defined, and there's lots of reasons why you want to keep your inventory down in case a part changes, in case you find a defect in something. You want to keep as little whip in process that will keep your machines operating and keep your people having some work to work on without going overboard and having extra whip that adds to your inventory holding cost. So that's what I got here for standard whip. Hope you learned something, and have a good day.